Hi, if you're watching this video, I'm going to assume that you already know how the different types of transformations work. You already know what a translation is, a rotation, and a reflection, and you want to see how these things can be put together. So I'm going to focus in on one type of composition of transformations, and that is called the glide reflection. And again, this is just one type of composition of transformations. All right, so let's look at what a glide reflection is. After that, we'll quickly discuss how we can do different types of compositions. Okay, so a glide reflection is the composition of a translation followed by a reflection. Let's write that down. Ooh, that's an M. Composition of a translation followed by a reflection. And so that reflection that happens at the end has to be in a line parallel to the translation vector. And this will be clear in just a moment. So, for example, I'm going to show you with just an image first. We're just going to move it around the page so you get the idea. And then we're going to actually do one in the coordinate plane. Okay, so here we have a footprint, and I like to use the footprint because of the curvature of the figure. So you can see this is definitely a left footprint. All right, so I'm going to move this. I'm going to use a translation and move it in the direction of this vector. So when I move it, here is what we get. Okay, so it's not officially in the coordinate plane, so I'm not really worried about how far I moved it. But of course, if this were in the coordinate plane, I'd say I'd moved it up however many units. But we moved it. All right, now when I'm ready to reflect it, for a glide transformation, my reflection line, my line of reflection has to be parallel to my vector. So that's supposed to be a vertical line, and that's my line of reflection, and I'm going to take this footprint, the one that was moved, and I'm going to reflect it over that line of reflection. Okay, and so that is the reflection of the new image. So our original image, let's call this foot, just call it foot. And then our translation, let's call it foot prime. And then our reflection, we can call that foot double prime. So we moved this twice, and that's how you do a composition of transformations. So we can have a rotation with a translation, we can have a rotation with a reflection, we can have all kinds of stuff. We can move whatever we want. As long as we're doing congruence transformations, we can do multiple ones together. So let's do another glide reflection, but let's make it official this time. Let's make it on the coordinate plane. Okay, so here we have a triangle, and we're being asked to do two things. We're first being asked to translate it along the vector 0, 4. So that is no movement in the x direction and up in the y direction, 4 units. And then we have to do a reflection of our image in the y-axis. So let's go ahead and figure out what the coordinates would be for our translation first. So our translation, so we're going to call it J prime, is up in the y direction. So we're going to have our x just be x, is not changing at all, but y we're going to have to add 4. All right, so go ahead and do that. We get x is still 6, but this time y is 3. And for k prime, x is not changing, so it's still 10, but our y we're adding 4, so we get 2. And for L prime, x is still 5 because it's not changing. And for our y, we're adding 4, so we get 1. All right, so that's enough to do our translation. And so as you can see, everything is moving up. It's moving, the translation is in this direction. All right, so I'm going to pick a different color. and plot those points. So we have 6, 3. So that is about right here. And 10, 2. So that is somewhat right here. And 5, 1. That's right here. And we've translated our triangle up 4 units. Now we're being asked to do a reflection in the y-axis, and the y-axis is right here. And as you can see, it is parallel to the translation, so this is in fact a glide reflection, which doesn't matter. Even if it wasn't a glide reflection, we could still do it. Now before we do our reflection, let's just make sure we have our points labeled so we are keeping everything straight. So that's L prime that we moved up. That is J prime, that's J moved up. And that is K prime, that's K moved up. All right, now we're ready to do the reflection. So here's the cool thing about having our line of reflection as the y-axis. It makes it a little bit easier because everything will be on the same horizontal. So L, the reflection of L prime, will be on this line somewhere, and it will be equal distance from here to the y-axis, will be the same again as from here to the new image. So I'll repeat. L, focusing in on L for a moment, from here to here will be the same as from here to the new image. So that means our y coordinates will stay the same for each of these points, but the x coordinate will just be the opposite sign. So with that said, we can figure out that J double prime is, again, x is the opposite sign, so -6, but the y coordinate will stay the same because it's on the same horizontal line. K double prime will be opposite sign for x, so -10, 2, same horizontal, and L double prime will be -5, 1. All right, so let's see what this did. For J, we have -6, 2, 3, 4, 5, 6, 3. So that is our reflection of J, and it does look like it is equal distance to the y-axis, so that's good. That's J double prime. All right, K double prime is -10, 2, so that's all the way over here. And L double prime is -5, 1, so right here. So our reflection of the translation looks like this. So now we have everything that the question is asking for. We have our original image here. We have it translated up to here. And then we reflected that image along this line to over here. And that's how a glide reflection works. And again, you could go ahead and just move things around, you know, flip them over, reflect them, rotate them, all kinds of stuff. As long as you're doing each transformation one at a time, just follow the rules for each transformation and then do the next transformation until you've followed all the rules. And that's how a composition of transformations work.